Imagine an operating room in the near future. There are no surgical scalpels gleaming beneath bright lights, and no clanging metal instruments. Instead, there are beams of pure light, precisely directed, targeting only the diseased cells and destroying them without touching the surrounding healthy tissue. This scene may appear to be drawn from science fiction, yet it is the future being pursued today by a Saudi scientist inventor who stands at the forefront of a global medical revolution. She is Professor Ghada Al-Mutairi, the mastermind behind technologies that may redefine the very concepts of surgery and therapy. Professor Ghada Al-Mutairi became famous for her most revolutionary invention, ultra-fine nanoparticles that allow light to penetrate the human body and activate medication in an exact spot. A breakthrough the media has dubbed surgery by light. But the question arises, how did a young woman from the Kingdom of Saudi Arabia reach a position where she is redrawing the boundaries of medicine? The answer is not a conventional success story, but an inspiring tale about a door that closed in her face, only to open for her doors to an entire universe of possibilities. This is the story of how a rejection from a university admissions office became the driving force behind one of the most important scientific careers of our era. A story of resiliency, of unquenchable curiosity, and of the power of a single mind to change the world. Ghada Al-Mutairi's journey did not begin in the advanced laboratories of California, but in the space between two cultures. She was born in Portland, Oregon, to Saudi parents, while her father was on scholarship, and this dual upbringing granted her intellectual flexibility and the ability to navigate two worlds, an asset that would later become strategic. Yet the deepest influence in her life came from her mother. In many interviews, Ghada gratefully points out that her mother was the primary engine behind her scientific passion, saying in her own words, "My mother studied chemistry. We are who we are because of her." This mother was not merely a caregiver, but an architect of a unique intellectual environment. She dedicated her life to her 5 children, who all pursued paths in medicine and science, turning their home into something akin to an incubator of scientific excellence. This intellectual ecosystem was not merely moral support, it was an effective network that produced tangible outcomes. Her later collaboration with her brother, Dr. Khalid Al-Mutairi, a renowned plastic surgeon, to develop a new chemical method for fat removal was not simply a family partnership, but the natural result of cross-pollination among different scientific specialties within this unique incubator. She was educated in the schools of Jeddah, where she began to be attracted to the language of science and its inner structure, an early passion that foreshadowed her future work in studying precise molecular architectures. Those formative years laid the foundation for a brilliant scientific personality, driven by boundless curiosity and fortified by a family environment that believed science was her highest calling. At the heart of every great story lies a pivotal moment, a turning point that changes the course forever. For Ghada Al-Mutairi, this moment was a letter of rejection. Her initial dream, like that of many ambitious people, was to become a doctor. She applied with full confidence to the prestigious medical school of King Abdul Aziz University in Jeddah, expecting to embark on her journey to treat patients. But the door closed. The rejection was not due to a lack of competence or intellect, but to a small yet decisive bureaucratic detail. She had studied in international schools whose curriculum included subjects such as music, which were not counted in her GPA in the strict manner required by the medical school's admission criteria. This reason lends a poignant human touch to the story, for it was not an academic failure, but a collision of different educational systems. This rejection could have been the end of her dream, but for Ghada, it was the beginning of everything. Instead of surrendering, she made a decisive choice. She shifted her ambition from practicing medicine to inventing it. She packed her bags and moved to the United States, enrolling at Occidental College in Los Angeles to study chemistry, the field her mother loved. There she excelled remarkably, continuing on a rigorous academic path to earn a PhD in materials chemistry from the University of California, Riverside, and then a prestigious postdoctoral fellowship at the University of California, Berkeley, under the supervision of the renowned scientist Professor Jean Fréchet. That rejection was not an obstacle to her medical dream, but the catalyst that elevated it to a higher level. Fate forced her to leave the physician's path, one that might have allowed her to treat thousands of patients, and guided her toward the path of the inventor who could change the lives of millions, indeed billions, by creating entirely new therapeutic platforms. That was her moment of destiny, the point at which she was steered, unknowingly, toward a much greater purpose. Once Ghada Al-Mutairi found her way in the realm of materials chemistry, she unleashed her genius and initiated a quiet revolution in nanomedicine. Her inventions were not incremental improvements, but quantum leaps based on one simple and elegant principle: stimulus-responsive materials for controlled activation. She mastered this core idea and applied it to solve a wide array of medical problems. One of the major challenges in medicine was how to deliver potent drugs only to diseased cells, sparing healthy tissues from harmful side effects. Ghada's answer to this challenge was the invention of the first polymeric nanoparticle chemically responsive to inflammation. Imagine an ultra-small capsule measured in billionths of a meter, loaded with a drug. This capsule floats inertly in the bloodstream, but when it reaches an inflamed area, it detects the chemical fingerprint of inflammation, specifically hydrogen peroxide. Only at that moment does the capsule break down, releasing its medication with pinpoint accuracy, like a smart bomb that targets only the enemy. Her most celebrated breakthrough came when she discovered a unique polymer that allows near-infrared light to safely penetrate human tissue at depth. This discovery was the key to fulfilling the dream of surgery by light. The concept is brilliantly simple. The drug is enclosed within a nanocapsule responsive to this kind of light. The capsule remains inside the body until a physician directs a harmless beam at the target site, say a cancerous tumor. Only then does the capsule open, releasing the drug precisely where it's most needed. This enables ultra-precise therapy, without surgery and with minimal side effects. Ghada Al-Mutairi did not stop at academic success. She sought to translate her research into real products that benefit people. In collaboration with her plastic surgeon brother, she worked on developing a new fat removal technique using laser energy to convert fat into heat, another application of the controlled activation principle, this time with a thermal trigger. This project led her to found her own company, Elux Medical Inc., to develop and commercialize the technology. Her numerous patents were not confined to medicine. Some were licensed to global pharmaceutical companies and even agricultural firms, proving the wide-ranging impact of her mastery in material science. Professor Ghada Al-Mutairi's achievements did not pass unnoticed. The scientific world quickly recognized the scale and importance of her contributions, and the awards and honors that followed were not mere decorations, but testimonies to her stature as one of the foremost scientists of her generation. The journey began with the NIH New Innovator Award in 2009. This $3 million grant is not given to conventional research, but reserved for bold, unconventional ideas that carry high risk yet promise revolutionary returns, the very essence of Ghada's work. In 2012, she received recognition at the highest levels when her nanoparticle invention was highlighted before the U.S. Congress as one of the four most significant American technological breakthroughs of that year. This accolade elevated her from a successful scientist to a national treasure of innovation. Next came the HEN Scientific Creativity Award in 2013, where her project was chosen as the best among 10,000 researchers, underscoring her overwhelming superiority in an intensely competitive field. In 2016, she was named a Kavli Fellow by the U.S. National Academy of Sciences, a prestigious honor bestowed on promising young scientists in the United States. Her influence was not limited to research, it also extended to spreading knowledge. She authored a book titled Precision Technology, which was translated into global languages such as German and Japanese, reflecting the wide reach of her ideas and global impact. Behind the impressive list of achievements and awards stands a multi-dimensional personality, revealed by her words and interviews, a unique mindset that is the secret of her success. The first striking trait is her deep humility. Despite all she has achieved, she still sees herself midway on her journey. She says, "I now feel I'm on the path and I can see the goal I dreamed of. I still haven't reached it." This sense that the best is yet to come keeps her flame of ambition burning. Her primary driver is curiosity. She believes in the importance of radical research that may initially seem impractical to others, yet carries the potential for tremendous impact. This pursuit of deep knowledge sets her apart. She is not looking for easy solutions, but for fundamental principles that can change the rules of the game. She also handles her